All right, let's finish this year 11 assessment review by going through one of the exams from last year. There aren't many exams at NCEA1 anymore, but here's one that was given last year. Mathematics and statistics demonstrate mathematical reasoning, which pretty broad. So I'm just going to be doing this the first time I'm looking at them. I sort of saw them, but I haven't actually done them. And I'll just be using a Casio calculator. Okay, let's have a look. So the perimeter of the shape is the distance around the outside of the shape. Hopefully you know that. The perimeter of the rectangle shown is 56 centimeters. And here's one of the sides, here's the other side. Form an equation and solve to find the value of x. Okay. So if this side is 2x plus 3, this side must also be 2x plus 3. And this side is 3x minus 5. This side must also be 3x minus 5. So the perimeter is 56 in total. Okay, so the perimeter is going to be equal to 2 times 2x plus 3, and they've even put it into brackets for you, plus 2 of the 3x minus 5. And we know that it comes to 56. And now we're just going to solve this for x. So let's get rid of the brackets here. So 2 times 2x is 4x, 2 times 3 is 6, plus 2 times 3x is 6x, 2 times negative 5 is negative 10, equals 56. So 4x plus 6x is 10x, 6x minus 10x is minus 4, just minus 4 equals 56. I think I can see where this is going. We're going to add 4 to both sides. So 10x equals 60, and then we're going to divide both sides by 10, like a 6 again. So x is going to be equal to 6. And centimeters, I guess would be, yes. All right. All right, next question. And a triangle ABC, the length of side AB equals y. Okay, so the triangle is ABC, y. AC is k centimeters longer than AB. So AC is k centimeters longer than AB plus k, but we know that AB is y. There's going to be y plus k. Okay. BC is 4 centimeters shorter than AC. So BC is going to be equal to AC plus 4, isn't it? Yes. So if we add 4 to AC, no, we subtract 4 from AC, we're going to get BC. But we know that AC is y plus k. So it's going to be y plus k minus 4. I suspect this is the form, these ones here are what we're going to be looking for. The perimeter of the triangle is 5 times the length of AB. So the perimeter is 5 times AB, and AB is y. Okay. Find the perimeter of the triangle ABC, giving your answer in terms of K. Okay. So we want to get rid of those Y's. So the perimeter is going to be AC plus AB plus BC. Okay, so AC is going to be Y plus K plus, and AB is Y, and BC is Y plus K minus 4, and we know that that equals 5Y. Okay. That's interesting. All right, so let's collect up all of these terms. So y plus y is 3y plus 2k minus 4 equals 5y. I hope that's how we do it. Now we want to get rid of the y, so let's solve for y. So let's bring this minus this 3y over. So 2k minus 4 equals 2y, and let's divide both sides by 2 here. So y is going to be equal to k minus 2, yes. Okay. So the perimeter we know is 5y, and if y is that, then the perimeter must be equal to 5k minus 2, which is 5k minus 10. I think that's right, yes. Oh, there you go. All right. The diagram shows the vertical line PT, which vertical, I guess, means up and straight up and down, is 8. B, C, D all join to T, so these must be straight lines. P, B, D, P, B, C, and D form a rectangle. Okay, so this is a rectangle. So these angles here must be 90 degrees. And they are perpendicular to PT. So this is flat and this is straight up. So these are perpendicular to each other. Okay. PT equals 8, so that's given. DC equals 12. BC equals 10. Calculate the length of the line CT. C to T, showing you're working. So C is there. They want the length of this line here, I guess. Okay. So, really what they're looking for, what we need to find first, we need to find that line there, don't we? And we can find that because this is a right angle here. This is 12 here. This must be 12 here as well. So PC squared must be equal to 10 squared plus 12 squared. Pythagoras is there. Okay, so PC is going to be equal to square root of 100, which is 10 squared, plus 104. Square root of 244, which I have no idea what that is. 244. So it's going to be 15.62. Okay, so it's 15.62. I'm just going to leave it as square root of 244 for now. And now we know that this side here is 8. So if we kind of look at it from the side now, this is going to be PT. So this is this line here. It's going to be this line here. And then sort of this line here is going to be this line here. We know that this is square root of 244. And we know that this side is 8. We want to find this length here, and we know that there must be a right angle there because it's vertical. So PT squared plus, we're looking for TC, aren't we? So TC squared, that's this line here that we're trying to find, must be equal to PT squared plus TC squared. Yes. Okay, so that's going to be equal to the square root of 8 squared, so 64 plus, and square root of 244 squared is 244. So the 64 comes from 8 squared. This side here. So it's going to be the square root of 64 plus 244. That is off the top of my head. Square root of 64 plus 244. So 17 point. 17.55 meters. Beautiful. And we're done. Alright, this next one, I always hate these questions. A sphere is a three-dimensional object shaped like a ball. Okay. A diagram shows a rectangular box containing 6 spheres, which would be that one there. The diagram also shows the same 6 spheres packaged in a cylindrical tube like a tennis ball container. The spheres fit tightly into the box and tube as shown. Okay, the spheres in the box, in both the box and the tube, are exactly the same size. Well, if they're the same spheres, then yes, they would be. The volume of each sphere is 150 centimeters. Show clear working to decide which container, regular or cylindrical, has the greater empty space by calculating the percentage of empty space inside each container. Right. Let's do this one here first. I think I know how to do this one. So if we look at each ball, it's going to have a radius. I think that's how we're going to need to do it, because this one here we're going to need to use a formula. So the radius is the distance from the center of the ball to the outside. So it's going to be 2r that way, and then 4r this side, and then this side here is going to be 6r on this side. So the volume of this one is going to be 2 times 4 times 6. Is that right? 2 times 4 times 6. 48. 48r cubed is going to be the total volume. So the volume of the, let's say, the container. And then this one here, the volume of this, what are we going to call this? This cylinder is going to be equal to 2 pi r, which is the area at the top here, times the height. And the height is going to be 12r. Isn't it? 2 pi r times 12r. No, it's going to be pi r squared. Ooh. 2 pi r is the circumference times 12r. How can we have r squared? R squared is a volume. Okay, so it's going to be the volume there. So the volume is going to be 12 pi r cubed, isn't it? Yes. That's going to be the volume of the cylinder, and the volume of the spheres in terms of r. So each sphere is 4/3 pi r cubed, and there are 6 of them. So that's going to be 24 pi over 3 r cubed, which is going to be 8 pi. 24 divided by 3 is 8 pi r cubed. That's going to be the volume of the 6 spheres, which is 150 centimeters. Okay. So the volume of the container is 48 r cubed. So that means that the volume of the spheres divided by the volume of the container, I'll call it CON, is going to be 8 pi r cubed. And I think they're going to cancel. Yes, they are. Divided by 48 r cubed, which is going to be 8 pi over 48. So that's what's going to be filled up by the spheres. And then the amount that's empty is going to be 1 minus that. So that's going to be the amount that's empty in the container. Maybe this isn't entirely clear, but it's going to be 1 minus 8 pi over 48. Close. So that's going to be 47% of the container is going to be air. And then if we work out how much of the cylinder, the round cylinder, is going to be air, well, we work out the volume of the spheres, which is 8 pi r cubed again, divided by the total amount of the sphere. Those 8, cylinder itself was 12 pi squared, and the amount that's air is going to be 1 minus that. So 1 minus, so they're going to cancel. I's are going to cancel. minus 2/3. So it's going to be 1/3 of that is going to be air. So 33.3% is going to be air in the round cylinder, and 47% of the square container is going to be air. So most of the air, that's the least efficient way of stacking the tennis balls and packing the tennis balls. Alright, on to question 2. The diagram shows a rhombus, so a quad with 4 equal sides shape. So a rhombus with 4 equal length sides. The length BD is 10 centimeters. So this line from here to here, this line here is going to be 10 centimeters, and the length of the perimeter is 60 centimeters. Find the length of the angle X, so that's this angle here. Okay. So if it's 10 from here to here, it must be 5 from here to here. And if all of these are the same length and all of them added together, so the length of each side must be 60 divided by 4, which is 15 centimeters. Okay, and we have a right angle triangle, so we can find this angle now using trig. So let's call that theta. Let's just sort of draw that here, and we know that x is going to be 2 times theta. We know that this side is 5 and this side is 15. Okay, so what have we got? We've got the opposite side there, we've got the hypotenuse side there. We are looking for theta, so we're going to use sine. So theta here is going to be sine -1, opposite over hypotenuse, so 5 over 15. All right. So sine -1, in fact, I'll just make sure we're in degree mode. Yes, we're in. So shift sine -1, 5 divided by 15, so 1/3, equals 19.471. degrees, and x is going to be 2 times theta, so I'm going to multiply that by 2, so 38.942 degrees. So x is going to be 38.942 degrees. There. Alright, next question. The diagram below shows the rectangle, so right angles, with a grey strip through it. FB and EC are parallel. Okay, so these must be parallel as well if this is a rectangle. CED is equal to ABF, which is 33. Okay, so there's 33 degrees. This is 2, and this is 28. Okay. Find the area of this strip BCEF, so this grey strip here. Alright, so if these two are parallel and these two are parallel, it's a parallelogram. Might not look like it, and it looks tricky, but I don't think it's actually as hard as it looks. Well, as tricky as it looks. So the area of a parallelogram is the base times the height. The base is going to be 2. The height is going to be this one there. So there's our base there, 2, because it's given. So we need to find this height. We've got the theta angle, and we've got the adjacent side, because it's a rectangle, so it's going to be a right angle. So we need to find this side here. So got the theta angle, we've got the adjacent angle, and we're looking for the opposite side. So we're going to use tan. So the tan, so it's opposite over adjacent. Got the adjacent. So the opposite side, so DC here, which is the opposite side, is going to be equal to tan of 33 degrees times the adjacent side, which is 28. Okay, now we're cooking. Tan of 33 times 28 is that. And so that's the height. And we know that the base is 2 because they just give it to us. So the area is going to be 36.367. So the area is going to be 36.367 meters, and its area, so it's going to be meters squared. Okay, so just to recap, we got the base, we need to find the height. We get the height by using trig on this right angle triangle here. Alright, next question. So the diagram below shows a prism with a rectangular base ABCD, right? Cross section ABFE. BFE, this one here, is symmetrical prism, okay? So in other words, you can draw like a kind of a mirror down there. Trapezium with AE equals BF, okay? So this side here is the same length as that side there. AB, this length here, is 4K. EF is 2K. And BC equals 8K. And this angle here, ABF, is 60 degrees. Show that the length PF equals 1.7321 K meters. Okay, let's see what we can do. So if this is 2, this is 2, this is 4, then this must be 1K here. So this triangle here, let's sort of redraw it to the side. This is 1K. This is 60 degrees. Then they want PF, which is this side here. They want that side there. Okay, so we've got the adjacent side. We're looking for the opposite side. So we're going to use tan to find that because it's a right angle triangle. So the opposite side is what we're looking for. We've got the adjacent side. We've got the theta angle. Opposite and adjacent, I'm going to use tan. So this is where it's that little triangle. So I'm looking for the opposite side. So it's going to be tan of 60 times K. Okay. So P side PF is going to be tan of 60 times K. I think tan of 60 is square root of 3, I think, from memory. think it's one of those special ones you're supposed to remember. Yes, and I think that's square root of 3. So, but it is 1.320, and then if we round it up 4 decimal places, it is going to be that. So let's copy that number there, which is 1.73205, which is 1.7321 K or dp. Cool. Okay. That was easy. Oh, okay. There's two parts. Given that the volume of the prism is all of that, 649.15 meters cubed, find the value of K. Okay, so the volume is going to be this area, this face here, whoops, times the depth. So this is a trapezium. So the area of this trapezium is going to be 2K plus 4K divided by 2 times the height, which is 1.7321 K. That's going to be the area there, and then we're going to multiply that by 8K, and we're told that that comes to 649.519 meters cubed. So let's just simplify it a little bit. So 6K divided by 2 is 3K times 1.7321 K times 8K equals, and because I'm just super lazy today, I'm just going to put that straight in the calculator. So 3x times 1.7321 x times 8x equals 649.59 equals 2.4909 meters. So essentially 2.5 meters. All right, question 3. I think there are only 3 questions. So find the coordinates of the y-axis intercept for the exponential graph y equals 5 to the power of 3x plus 2 plus 4. All right, so what's the general rule to find the y-intercept? We set x equal to 0 and then solve for y. So y is going to be equal to 5. 3 times 0 is 0 plus 2 plus 4. 5 squared is 25 plus 4 is 29. So the intercept, sort of put it in there, is going to be at 0, 29. So far, so good. Sequence is shown in the table below. So it's going up by different amounts. So it looks obviously not linear. It looks like it's quadratic, but let's test. So 35 minus 24 is 11. 48 minus 35 is 13. 63 minus 48 is 15, okay, and 80 minus 63 is 17, so it's going up in lots of 2, so yep, it's quadratic. It's going up in lots of 2's, so therefore it's going to be in this form: y equals ax squared plus bx plus c. And now it's actually a simultaneous equation. So let's take one of these points. So it says that wherever x equals 1, y equals 24. So we're going to substitute 1 wherever we have an x and 24 where we have a y. So let's do it sort of the other way around. So a times 1 squared is a, plus a times 1 is b, plus c equals 24. And then when we have another equation, let's choose 2. Wherever we have an x, we're going to put a 2. Wherever we have a y, we're going to put 35. So let's so 2 squared is 4 times a, plus 2b, because b's there. There's just the c just goes along for the ride, equals 35. Now let's do this one here. Let's do the 4-bit. So 4 squared is 16a, plus 4b plus c equals 63. And now we have 3 equations and 3 unknowns. We have a set of simultaneous equations. And I'm going to be very, very lazy, and I'm just going to use the calculator. 3 unknowns, 1b, 1a, 1b, 1c, 24, and 4a, 2b, 1c, 35. Now 16a, 4b, 1c, 63. And now we want to solve 1, 8, 15. So the equation is y equals 1x 15. And the next one was 8 and 15. Plus 8x plus 15. All right. Let's do it in the calculator just so you can see that we could actually do it like that if we knew that it was quadratic. Let's go to stat mode. Put these numbers in here like this. 4, 5, 24, 35, 48, 63, and 80. I'm going to graph it. Graph 1. Yeah, it looks like a parabola. Calculate x squared, 1, 8, 15. We draw it, it's going to look like that. Fair enough. Fantastic. If the graph is drawn for all values of x, identify the features of the graph of y using this equation. All right. So if we draw it, y equals x squared plus 8x plus 15. So 3 features. So let's use the x-intercept, the y-intercept, and the turning point. Okay, so the y-intercept is going to be at 15. Just is. The x-intercept. Ooh. Go to grapher. Just go to grapher. X squared plus 8x plus 15. Now I'm going to zoom out. Zoom out there again. Okay, so it's going to look like that. And now I'm going to find the x-intercepts, the roots. So I'm going to go to gsolve. First root is at -5. The other root is at -3. And the turning point, gsolve so it's going to be a minima point, is going to be at -4, -1. Okay, so if we come to graph it, it's going to kind of look like that. 15, and it's going to be at -5 and -3. 3 features. Fantastic. All right. Use the diagram below to help you. So the points 5, 4, that's that one here, and 9 minus 2 are on the blue line. Find the equation of the line. Okay. So you have to remember your two equations. M equals y1 minus y2 over x1 minus x2. So y1 is, let's call this one 1 and this one 2. So y1 is going to be 4 minus 2 is going to be plus 2 over 5 minus 9. So it's going to be 6 over minus 4, which is minus 3 over 2. Okay, so that's going to be the gradient. And now y minus y1 equals mx minus x1. So y minus y1 is 4 equals minus 3 over 2 x minus x1, which is minus 5. So let me y equals minus 3 over 2 x plus 15 over 2 plus 4, because we bring this 4 over. So 15 over 2 plus 4. God. 7.5. 15 divided by 2 is 7.5. Plus 4 is going to be 11.5, isn't it? Yes, 11.5. So this graph has the equation y equals minus 3 over 2x plus 11.5. Okay, second line has this equation, x minus y2 minus 9 equals 0. Find the coordinates of the point where the lines F and G intercept each other. Okay, I'm just going to copy this one down. X minus y2 minus 9 equals 0, and y equals minus 3 over 2 x plus 11.5. So let's have these in let's just kind of move this into the form that we want. So minus 2y equals minus x plus 9. I just brought the x in the minus 9. So y is going to be equal to half x minus 4.5. So now they're in the form that we want, and now we would be justified in just using the calculator, to be honest. I know it probably is cheating, but x minus 4.5, one of the graphs, and this one is minus 3 over 2, x plus 11.5. Draw both of them. Zoom in a little bit. Okay, and now we want to find where they intercept. So I'm going to go to gsolve, and they cut at 8 and negative 0.5. 8, negative 0.5. Okay. I think this is the last question. Given that 3 to the power of 2x plus 3 times 9 to the power of x equals 3, 4 minus 3y, find an expression for y in terms of x. Okay. So our problem is this 9 to the power of x here. But remember that 9 is equal to 3 squared, because we want them the same base, and the base of this is 3. So 9 is the power of 3x squared, so therefore 9 to the power of x must be equal to 3 to the power of 2x. Yes. Now we can rewrite this. Now when we multiply them, we're going to add these together, aren't we? Okay. Now we're going to add these together. So 2x plus 3 plus 2x equals 3 to the 4 minus 3y. So 3 to the 4x plus 3 equals 3 to the 4 minus 3y. Now remember, if we have a to the power of m equals a to the power of n, m must equal n. These have the same base. So 4x plus 3 must equal 4 minus 3y. And we want y in terms of x. So let's bring this 4 over. So take 4 away. Just going to move it up here. So 4x minus 1 equals minus 3y. So y is going to be equal to 4x minus 1 divided by negative 3. So it's going to be 1 minus 4x over 3. And we're done. I think that's the last one. Yes, it's the last one.